Hi guys! In this lesson, I will explain one of the most important issues that we need to know in order to analyze electrical circuits. Kirchhoff's laws is one of them. There are two laws, current and voltage. Although it seems very simple, we unfortunately have difficulties in other subjects when we do not learn the basics well. In this video, I will explain Kirchhoff's voltage law. In the next lesson, I will explain the current law. First of all, we need to determine the direction of the current in a circuit. It is very easy to see the direction of the current in this circuit. It will be from the positive pole of the source to the negative pole. But in circuits where we can't see the direction clearly, don't worry if I can't find the direction of the current. We can estimate a direction. If the current value we find is positive, the direction we determined is correct. If the current value we find is negative, it is in the opposite direction of the direction we have determined. Now let's write the voltage values on each resistor here. The part where the current enters will always be positive. Let the voltage across the resistor R1 be V1, the voltage across the resistor R2 be V2, and finally, the voltage across the resistor R3 be V3. Here, resistors are circuit elements that consume voltage. This is where Kirchhoff's voltage law guides us. According to this law, the sum of the voltages produced is equal to the sum of the consumed voltages. There is only one voltage produced here. It is the source voltage. If we denote this voltage as Vt, we will have Vt equals V1 plus V2 plus V3. In this formula, if we assign the value of Vt to the right side of the equation, it will be negative Vt plus V1 plus V2 plus V3 equals 0. So, from this formula, we can say the following. The sum of all voltages in a circuit is equal to 0. Kirchhoff's voltage law is basically like this, folks. Most of the circuit analysis is built on this. The sum of the voltages produced is equal to the sum of the voltages consumed, or the sum of all voltages in a circuit is equal to 0. Now, let's try to understand this formula better through some examples. In this example, let's find the voltage across each resistor and the circuit current. In this circuit, the direction the current goes is clear. Let's find the current value first. Accordingly, let's write the voltages on the resistors as V1, V2, V3. Now we can write Kirchhoff's voltage law. The sum of all voltages with respect to the direction of the current will be equal to 0. From which end of the circuit element the current enters, we do the addition process according to the sign there, friends. We know that V1 is I times R1, V2 is I times R2, and V3 is I times R3. Let's substitute these values into this equation. From here, the main current value will be 45 volts divided by 22.5 kiloohms. At the end of this process, the current value becomes 2 milliamps. We found the current in the circuit. Now we can find the voltage values on the resistors. V1 voltage will be 10 volts from 2 milliamps times 5 kiloohms. The voltage of V2 will be 20 volts from 2 milliamps times 10 kiloohms. The voltage of V3 will be 15 volts from 2 milliamps times 7.5 kiloohms. Here we see that the sum of the voltages consumed on the resistors is 45 volts. The generated voltage was equal to the consumed voltage. In addition, the voltages of the resistors were directly proportional to the resistance values. It is not necessary to solve this example in this way, friends. If you wanted, you could first find the total resistance and find the current value from there. But in complex circuits, we will definitely need to solve this way using Kirchhoff's voltage law. Now let's do an example where there are two voltage sources. One of the sources is named VA and the other is named VB. In this circuit, it may be difficult to see which direction the current is in. This is no problem, guys. Again, let's assume that the current is clockwise. Then, let's write the voltage values of the two resistors according to this current direction. When we write Kirchhoff's voltage law according to this current direction, it will be negative VA plus V1 plus VB plus V2 equals 0. We know that V1 is I times R1, V2 is I times R2. Let's substitute these values. From here, the current value will be negative 20 volts divided by 5 kiloohms. At the end of this process, the current value becomes negative 4 milliamps. We saw that the current was negative coming out. Well, what does it mean? In other words, the direction of the current is actually counterclockwise, not the clockwise we assumed. We have also seen the example that I tried to say at the beginning of the video. We can also rewrite the plus and minus directions of the voltages on the resistors according to this current direction. We found the current in the circuit. Now we can find the voltage values on the resistors. V1 voltage will be 8 volts from 4 milliamps times 2 kiloohms. The voltage of V2 will be 12 volts from 4 milliamps times 3 kiloohms. Here we see that the sum of the voltages consumed on the resistors is 20 volts. So, is the generated voltage equal to 20 volts? Since the generated voltage is VB minus VA, it is also equal to 20 volts. The generated voltage was equal to the consumed voltage. In addition, the voltages of the resistors were directly proportional to the resistance values. We can apply Kirchhoff's voltage law to all circuits, not just resistors. For example, if we write the voltage law according to the direction of the current in a circuit with a diode and resistor, it will be negative V plus VD plus VR equals 0. Similarly, we can write two different voltage laws in the BJT transistor circuit you see on the right. If we write for the first eye, it will be negative 4 volts plus IB times 20 kiloohms plus VBE equals 0. For the second eye, if we write it, it will be negative 6 volts plus IC times 100 kiloohms plus VCE equals 0. Kirchhoff's voltage law is basically like this. I hope this lesson was helpful and you liked it. I will explain Kirchhoff's current law. Hope to see you in the next lesson. Goodbye.